Today we're going to be talking about graphing from the vertex form. So the first thing we want to talk about is which form to use. So expressions in different forms can be used to define the same function. We talked about that yesterday where we had three different forms. Here are three ways to define a function. So we have f of x equals x squared minus 4x plus 3. That's in what we call standard form. F of x equals the quantity x minus 3 times the quantity x minus 1. That's what we call factored form. And f of x equals the quantity x minus 2 squared minus 1, which is vertex form. That's what we learned about yesterday. So which function would you use if you want to find the following features of a graph of f? So with this, the x-intercepts, remember those are what are on the x-axis. And so the easiest way to find that would be using factored form. Okay, so that's going to be where we can just take the opposite of those numbers, plot those two things, and those would be our x-intercepts. The vertex of this, that's going to be easiest to use vertex form. Remember, that's where we take the opposite of the number inside the parentheses to be the x-coordinate, and the number outside of the parentheses here after the parentheses is going to be the y-coordinate, and that just stays the same. For the y-intercept, the easiest one then would be standard form. We know that if we plug in 0 for x, we can automatically get the y-intercept would be 0, 3. Now that's pretty easy to do in any of them, but I would say standard form is the fastest to do that with. Okay. All right, let's move on to our next piece. So sharing a vertex. It says here are two equations that define quadratic functions. We have p of x equals negative times the quantity x minus 4 squared plus 10, and q of x equals 1/2 times the quantity x minus 4 squared plus 10. It says the graph of p passes through 0, negative 6, and 4, 10. So these two are already graphed on here. Okay, we're going to find the coordinates of another point on the graph of P, and we're going to explain and show our reasoning. Then we're going to use those points to sketch and label the graph. So if this is the vertex here, this is V, the vertex. Okay, we know that this is a point on our graph, on our parabola. This is the vertex. So if this is our what we call axis of symmetry, okay, if we have a point that is 1, 2, 3, 4 spaces to the left of the vertex, then we should be able to go 1, 2, 3, 4 spaces to the right and also have a vertex. We've talked about that a parabola is symmetric with respect to its vertex. So that means that 8, negative 6 is also a point on this. Now, we could also prove that by going up to the equation that they gave us earlier, this p of x function, and plugging in 8 there. So 8 minus 4 is 4, 4 squared is 16, times the negative is negative 16, negative 16 plus 10 gives us the negative 6. So now that we have those 3 points, we can use them to do the best we can to make a parabola. And they should get arrows on the end because it is going to keep going on forever in that downward direction. What about that equation told us it was going to face down? That it had the negative out front. Okay. Number 2 says on the same coordinate plane, identify the vertex and 2 other points that are on the graph of Q. So we know, looking at this equation, that positive 4, positive 10 is still the vertex. It also said in the directions or in the thing sharing a vertex. And then we have to find 2 other points that go with this. So pretty much all we need to do here is just be able to plug in some sort of number and see what we get out. All right, so if we plug in, let's just say 2. 2 is a pretty easy number to plug in. You can also plug in 0. That's not so bad to plug in. So if we plug in 2 here, 2 minus 4 is negative 2. Negative 2 squared is positive 4 times 1/2 is 2 plus 10 is 12. So we just produced a point 2, 12. If we have a point at 2, 12 and we go 2 spaces into the to the axis of symmetry, then we would need to go 1, 2 spaces out And so that means that 6, 12 is also a point on that. And you could do the same thing where you plug in the numbers to get that information. So now that we have both of these things here, this top one is Q of X, and this bottom one down here is P of X. So we'll label them as such, okay? All right. Pyra says, once I know the vertex is 410, I can find out without graphing whether the vertex is a maximum or the minimum of a function p. I would just compare the coordinates to the vertex with the coordinates of a point on either side of it. Complete the table and then explain how Priya might have reasoned about whether the vertex is a maximum or a minimum. So if we have our p of x function, okay, and we're plugging in 3 to that, okay, so if we're going to find p of 3, that means that we would take 3 and plug it into x for the p of x function that they gave us, okay? And when we do this, 3 minus 4 is -1, -1 squared is +1, times the negative is -1, plus 10 gives us 9, okay? So this is 9. And if we do the same thing for p of 5, okay, so we plugged in 5. 5 minus 4 is 1. 1 squared is 1. Times negative is -1 plus 10. That also gives us 9. So if you think about it, our vertex here is at point 4, 10. And then we have 2 points off to the side at 3, 9, and 4, 9. Does that mean that our vertex is a maximum or a minimum? Since 9 is less than 10, the vertex is a maximum. Okay, so I'll even add since 9 is less than 10, the vertex is a maximum. That is the highest point. All of these other ones get lower, and then they would keep getting lower as you went from there. Okay? All right, are you ready for more? It says, write an equation for a quadratic whose graph has a vertex at 2, 3 and contains the point 0, -5. So with this, if we know vertex form is the easiest to deal with. We talked about that yesterday. So we would have y equals, maybe there's some a value out here, we're not sure yet. And then x, it should be -2 since this is a +2 squared, and then +3 since that's a +3. But if we plug in 0 for this, okay, we get -2 squared, which is 4, plus 3 is not -5. So since we just got a number that's bigger than that, we know we need a negative number here. It's going to flip down. So making that be negative would give us, if we plugged in 0, so that would give us -2 squared is 4. 4 times -1 is -4 plus 3. So let's try putting a -2 there. Okay, so then that would give us 4 times -2, which is -8 plus 3, which is 5. Or -5, which is what we want to happen. Okay, and then for sketching, if we have our graph, so we know that 2, 3 was the vertex of this. We also know that 0, -5 is a point on this. So again, if you're looking at that axis of symmetry, since this point 0, -5 is 2 spaces away, we would need to go 2 spaces away over here at 4, -5. And then that would give us our points for our problem. Okay, so that's a quick sketch of that information. All right, the last piece that we're going to be dealing with is a card sort. So I'm going to show 6 equations and 6 graphs, and we're going to match them together. So here we have 6 graphs and 6 equations, and we're going to be matching them together. So let's see what we can do here. So these aren't in any such order necessarily, and that's fine. And then all of our equations are in vertex form. So here, if we're looking at this equation, p of x equals negative times the quantity x plus 1 squared minus 4, we know that this one needs to face down, and that its vertex would be at negative 1, negative 4. So which of these graphs face down and has a vertex at negative 1, negative 4? That is going to be graph D. Here's another one that is negative. Okay, so we have g of x equals negative 1 times the quantity x minus 4 squared plus 1. The only other one that faces down is graph C here. So then it does have a vertex at 4, positive 1. You got to be careful with what they're counting by on this one. In this case, they're counting by 2's on the y-axis. So that matches there. Next one, we have f of x equals the quantity x minus 1 squared plus 4. So this does face up. It does have a vertex at the point 1, positive 4. So which of these graphs has a vertex at 1, positive 4? That's going to be letter F. We have h of x equals the quantity x plus 1 squared minus 4. So we need a vertex at negative 1, negative 4. And it faces up, so that's going to be graph B. R of x equals the quantity x plus 4 squared minus 1. So we need a vertex at negative 4, negative 1, which is going to be graph E. And just to make sure, let's look at this. We have q of x equals 2 times the quantity x minus 4 squared plus 1. So it needs a vertex at 4, positive 1. And it does have a 2 with it. So if you notice, this graph in comparison to all the others does appear to be skinnier. And the reason for that being is that 2 there. Okay, so just based on knowing what direction it was supposed to face and what the vertex was, we were able to match all of those graphs with our equations. And that's it.